bit of context on exactly where the
Well,
decision was taken to switch.
As an advocate for the opaque params, I'll try to describe the thinking. I believe that the KEP was written with, the ideal end user interface in mind, which, I think having a first class params in your pod is a better sort of way to express this to end users. But the problem is that the actual implementation is way more nuanced and complicated than like a single number can really express, or even two numbers or three numbers. And in the interest of vendor adoption and allowing lots of experimentation and innovation, I think that the idea was opaque params let you still get the basic feature, slightly less nice documentable user interface, but you can get all kinds of capabilities and nuance, and we can work out some of the details of exactly how QoS should work. Like, should you have separate IOPS for reads and writes? Should you have floors? Should you have ceilings? Should you have targets? Should you have bands? All the different kinds of design decisions that we would ideally like to figure out, we can postpone and just let the vendors figure them out through an opaque interface. And then maybe someday in the future we'll actually converge and say, this is the one way to do it, and then do something different at that time.
Yeah, I would +1 to what Ben just said. I think at least on the AWS side, I know for a fact that a lot of our customers have asked for this kind of capability in the past, but it's not just limited to the QoS parameters. They have asked for similar support for things that may be related to potentially modifying characteristics of a volume. And at the time when we were thinking about this internally, we were trying to make sure that we did not limit ourselves in any way by picking options which would exclude certain capabilities in the future. So using the opaque parameters based approach seemed like the right step forward in that respect. And I think if I remember right, the original KEP did not advocate for that. And then we kind of talked about it over the last couple of meetings. And then that's how we kind of came to the conclusion that this had benefits which the original KEP, which thought of it in terms of just adding support for the IOPS parameters, that approach was going to be limiting. And so that's why we feel that I think going the opaque parameters route makes sense. So it's a little bit of a surprise to me at this point, given that we've had this discussion for close to 4 or 5 months, and then arrived at this conclusion that we are now going back and saying that the opaque parameter-based approach is not the right approach.
I'm just curious about for Azure. I saw that you have read-write IOPS and read-write throughput, but you also have read IOPS and read throughput, or separate, like write IOPS and write throughput. Like, if we don't go down the route to use opaque parameters, how do you think we can support those?
Well, I mean, in my mind, I thought it was most important to define what the API and the user experience should be first. And then it would be up to the storage providers to see how they can map their systems to them. I don't think it's a good approach to say that this is what everybody can support. Let's try and find a sort of lowest common denominator. I think there are some key values that if we could agree on, it would provide a better user experience. And I'm not convinced that we can agree. I just thought that the next step was to have that conversation about, can we find an agreement? I'm coming at this now because I hadn't realized that this is the path that was taken, and I probably missed a few meeting invites, so my apologies. I'm just commenting on the proposal as it stands now. So
Could you talk about what is the problem with the customer experience that the opaque parameter-based approach has?
So I think as storage providers, we've always been discouraged about adding provider-specific configuration to what should be a portable resource. The PVC is the portable resource. We've always been discouraged from adding annotations and things like that, PVC, to say configure per volume replication policies or something like that. Now, I don't see these opaque parameters in classes as being any different from that. They're very provider specific. And by having a class name, which is like gold or silver, that doesn't really mean anything to a user. They can't take that from one cloud provider to another.
But
so that last part is true. The meaning of any given performance class wouldn't be portable across clouds, but I believe that it's pretty evident from the different QS implementations that we see in the market anyways, that there isn't a single definition that would be portable. And that's part of the problem. If you say, look, well, it's going to be IOPS, then it's like, well, you better get everyone to agree what an IOP is in a way that like 4,000 on AWS means 4,000 on Azure and means 4,000 on NetApp. And it's like, that's very, very hard, right? To like, we all agree on what a byte is and what a byte per second is, but an IOP is just a little bit harder. And when you add in, you know, floors and ceilings and bands and targets and the possibility that some implementations will tie performance to capacity, it seems unlikely that the alternative would actually give the proposed benefit of portability. And so that it becomes like storage classes. You know, storage classes are also not portable, but they're a standard part of the API because it's a sort of a necessary evil to paper over these inevitable differences.
If I can add some thing, I think from what I've seen for companies that do like multi-environment deployments, and they have to manage infrastructure across multiple different environments, what I've seen how they work is they'll typically have like a platform team that is responsible for providing that layer to the app teams. And so I kind of see that parallel there between like, you know, the platform team is responsible for sort of defining some resources that can be portable across the platforms. So today, like the platform team would be responsible for defining a storage class across the different platforms that everyone can kind of rely on and get similar behavior. So I think the same parallel could be made for the performance class.
Yeah, I would agree with that. I think, at least in my mind, a lot of these parameters are going to be attributes of volumes that are going to be difficult to standardize and port across different vendors in a consistent way. And I think it will be difficult to take what is implemented on one provider by one provider and make it completely consistent across all providers because of the differences in the implementation. And what Michelle is talking about in terms of having a platform team, I think that's pretty standard. I also don't see how trying to standardize on this is going to get rid of that difference in the provider platform completely. I think for that to happen, we would need to have a much broader scope of standardization, similar to maybe not quite at the level of a byte, but we would need to have very clear definitions of what IOPS means, what throughput means, and what other parameters mean across all the different platforms. And I don't see that happening anytime soon. The other thing that I also want to emphasize here is that we are not talking only about performance characteristics or volumes here. There are other things that are of interest. As an example, on the AWS side, there is interest in exposing encryption settings eventually at some point in the future. And that would be something that would be relatively easy to do with the current approach. But if we decide not to go with the opaque parameter-based approach, then we now have to find a completely independent mechanism of essentially doing exactly the same thing. And that, in my mind, just does not seem like a good design. So.
No, we can definitely see the advantage of having a way of configuring opaque, like, SP specific configuration per volume in a class-based way. I'm not doubting that. I guess what I was thinking is that IOPS and throughput is something that, we could put a stake in the ground and say, this is what it means, because those two are well known enough. And, they're pretty much the concepts at least are industry standards, and they mean a lot to users. So if we could put a stake in the ground and say, well, this is like there's no such thing as a typical workload, but if you were to say it was, for example, a 50-50 random read-write workload, this is the expected IOPS that system could provide. If a system doesn't have those knobs, it might have to make some adjustments in order to guarantee those IOPS. I'm not saying that it has to be a one-to-one mapping to storage providers. It's just that this is what the application is requesting.
I think that even though, yes, we can all agree that a throughput number is sort of indisputable, that assumption, like 50-50 random read-write workload, is going to be violated all of the time, and with unfortunate results for those who have sequential read and sequential write style workloads, right? And then there's going to be pressure to say, well, let's treat read throughput and write throughput as two separate numbers. And then, and the problem is, if we've standardized on like just one number, and then we have to go back and redesign the feature to accommodate those kinds of changes. I don't think we can agree that, a megabyte per second is a megabyte per second. I don't think that's disputable, but like whether you want to limit reads and writes as one number or as two separate numbers, or do something more complicated, I think that is up for dispute.
Yeah. So there is a bit of precedence, like the CPU request, which is the number of shares. So that's not going to be the same performance depending on the node type that you land on, or the CPU type that you get. So it's not like these requests are guaranteed in the terms of it's going to be exactly the same on every platform. And I think that applies here as well.
That raises a good point, though, about what do you do about the fact that one CPU is slower than another CPU as you try to move across clouds? Do you just change your pod definition to require more CPUs on the platforms where it's slower and you need more? I actually don't know. I think that's a flaw, not a precedent to follow.
No, but I guess what I'm saying is, like, how guaranteed for every workload do we actually need to be, or can this just be a guideline that says, well, on whatever platform you're on, the SP is, you're making a request, and the SP should honor it. Now, there are also some, like if you look at how huge pages is defined, it's basically like a prefix. So there are sort of options for saying, well, we could have like the, generic IOPS, but we could also add a read-only or read-write IOPS to that as well.
But Simon, I feel like the downside of treating these two parameters as special far outweigh any plus side we might get from standardizing on just these two parameters. Like, I don't want us to go and build a different solution for everything else and just treat these two parameters as special. I don't think that's the right approach.
You're saying you think we're going to need mutable opaque parameters anyways? for reasons that have nothing to do with QoS, and we may as well just use them for QoS. That's the argument.
I'm saying that there is a lot of interest on the part of customers to see us provide capabilities which to see us provide a capability which can be used to modify volume attributes. And
Yeah.
I'm saying that instead of building 2 or 3 different mechanisms of doing that, we should build one mechanism which customers can rely on in a consistent way to make that happen.
I share that intuition. I think it would be good to spell out a few to make the point stronger. Earlier you mentioned encryption, and I was trying to respond, but I was on mute. I wanted to understand, by way of an example, why would you want immutable opaque parameters to enable encryption? Like, can you just flesh out that use case?
I mean, we don't have that use case yet. It is something that we have discussed in the past. I think Rishabh has a little bit more context around that, so he can probably provide more details as well. But my understanding is that one possible scenario where something like that might come in is if you want the contents of a volume to be encrypted, and maybe you want a way to specify the key that you use to encrypt that volume, or maybe modify that key in some way. I think that would be one use case for that to happen.
Yes, but like you couldn't use volume performance classes as proposed for that purpose, because there you just have these static classes that every volume has to share. You're describing like a per volume parameter that would be stored somewhere else in Kubernetes. Like the CSI layer could be the same. I agree with that, but you couldn't reuse volume performance classes to achieve that if you want a separate value per volume, for example. Well,
I mean, it is theoretically possible if you were modifying the volume, if you were modifying the encryption settings for a bunch of volumes that you're operating on at the same time. So a scenario might be the volume is unencrypted and you want to go ahead and encrypt it, and you want to maybe potentially set an attribute which would allow you to make that operation possible on the backend.
Okay. I mean, I think we should put a pin in the encryption use case, but it is an example of something else that the underlying CSI interface could be used for. And
I that may not be the best example that exists for this scenario, but I think there will be such examples coming up in the future, and I think there is value in trying to build a single solution that addresses all of those use cases.
Can now the APIs be extended when those use cases come up, like CSI, spec, and post Kubernetes APIs be updated? And I think that's one of the motivations like behind making them like explicit, so that I know it takes time for the specs to settle down in CSI and make change in Kubernetes, but
I think that's the main concern, right? Like, so for instance, as an example, we started the work on this sometime about a year back internally, and then we filed a KEP sometime around August of last year. We are now in June, and we are still not at a point where we have agreed on a solution. And in the meanwhile, we keep getting requests from customers saying, hey, this is really important to us. Can you do something about this? So like the solution that we built as an interim measure based on custom annotations, we wouldn't have had to build it if it hadn't taken this long for the entire process. And I'm not saying that it's anybody's fault, because it's not. I think these things deliberately take longer than expected, because there are a lot of different parties involved and this is open source. But at the same time, I think if we are going to build something, we should try to be a little bit forward looking and try to bulletproof it. So
I think sorry, Ben.
I was just going to say I'm torn, because I agree that like for certain things it is better to have a standardized feature, and I think that there's a gray area where it's impossible to standardize. I mean, there's a past a certain point, it's obvious that proprietary is the right way to go. And on the other side, it's clear that a standard way is the right way to go. And there is this gray area where it's like, yeah, lots of people have the same kind of feature, but nobody does it quite the same. And if we tried to get everyone in a room and agree on an interface, no one could agree. And I feel like we're there. and mutable opaque parameters feel like the right way to get over that hill.
I think that
Because go ahead.
I think that like the problem is like building something new. Like there was like modify volume, like something new was much more tricky to get it right, and we went through several iterations to get where we are. And but I mean, I'm big optimistic that like incrementally making changes is not as hard as like designing a feature from like
Right.
ground up.
Are you referring to the expand volume feature that took many iterations?
Yeah, expand volume took like a year, right? And
Yeah, but that was a case where like everyone understood what it meant, and no one was like, yeah, my expand works different than your expand. It was just that it was.
I was referring to in this case, like if we have a modify volume feature that's there in CSS spec and it has fields. So in future, if we need to add new fields, it's relatively less work in CSS spec modification and Kubernetes to add new fields and propose. Like for example, like let's say we had a good example would be secret for various CSI requests. We didn't add secrets to a lot of requests, and we have been incrementally adding them like to several RPC calls actually. And we have, so it's basically like that. Like we will be adding extra fields, whatever the justification will be. And it's not that hard.
But if you add new fields, like how like each storage provider is going to have fields that they want to add, right? Like in our case, in AWS's case, we have stuff like multi-attach that we want to add. Azure might have something else, GCP might have something else, and eventually I think we're going to all converge of this idea of having an opaque parameter approach that we're discussing right now.
We have opaque parameters, they're just not mutable, and I think they're heavily leveraged for a lot of these kinds of weird proprietary features that, you know, it doesn't make sense to spend a lot of time trying to standardize. And so the pain point has been, okay, you know, you can set QoS today using opaque parameters at creation time. It's just that you can't change it later, right? And that's what irritates people.
But like the various features we talked about, multi-attach, encryption, that scares me more actually, like because those things are different from performance class, QoS class that we're talking about, because those features have implication in terms of how external attacher and kube controller manager treats volumes. And so those, like, you cannot just add there's those parameters in a bag of map and expect everything to work.
The multi-attach one, I agree. That feels like a special case that should be handled, and I think we do handle it already. So, but we don't need to go there. But I think QoS is the perfect example of a situation where, you know, people are already setting these things through opaque parameters in the storage class, and then when they want to change them, they're stuck. And we can give them this mechanism. Remember, there's two different designs. There's the CSI layer design, where the current proposal is just this bag of strings, modify volume with opaque parameters. But at the Kubernetes layer, it is formalized into a volume performance class that is, you know, a non-namespace object defined by the administrator that you choose from. So it's like a menu of options you choose from. You can pick one option and then you can change your selection, but you can't change what the menu options mean. And that's I think a good amount of guardrails around the feature at the Kubernetes layer, because it lets you do things like quotas and control who can do what, and, you know, do the right kind of RBAC. If we were to expand this to do something around encryption, and I struggle to think about what that would look like, you might end up reusing the CSI layer modify volume feature, so no CSI change, but you would need to do something at the Kubernetes layer to have some per volume state that says what the old value was and what the new value is, and you'd have to have a reconciler that would reconcile them. to, get the desired result.
I think
so-
I'll say again, let's not use the encryption example as as representative of what else this might get used for, because that was just something that we have talked internally as an item that's possible in the future. We don't have any concrete plans around that at this point. So
I guess what I'm saying is we still have the opportunity to design features with, reasonably restrictive semantics at the Kubernetes layer. We're not just sort of throwing it open to, like the equivalent of taking all the annotations and passing them down, right? That has been proposed before, and we said, no, we're not going to do that, because then all hell will break loose. And it's probably for the best. This feels like something that's tractable. We talked through the RBAC implications of performance classes. We talked through the quota implications, and I think we felt comfortable that it's possible to have the right amount of control with this feature. And if it only ever gets used for QoS, I think the outcome will be good. And if it gets used for QoS adjacent things, I think it'll still be fine. I
think I would say that at this point, I don't anticipate, you cannot predict the future. You don't know how customers are going to end up using this kind of thing, right? Once it's built. But at this point, I feel like QoS adjacent items are basically what will drive the adoption of this use case. That's my sense. But I don't think that it's just those two parameters, IOPS and throughput. I think there may be other things that customers may be interested in doing,
I think you'll end up seeing very rich versions of QoS definitions that are more than just IOPS and throughput. I think you'll see floors, and I think you'll see ceilings. I think you'll see bands and targets. I think you'll see separations of reads and writes, maybe even down to separate numbers for sequential and random. I mean, I think you'll see people figure out what the right axis to slice is, and then come up with their performance classes based on along that axis.
I agree. I agree with that.
And I don't think we know today. I mean, we can make a guess as an engineering team and say, yeah, we think one IOPS number that's based on 50-50 random read write is the thing, and we could be wildly wrong, and then we'll be stuck. And we could do that, but I'm not in favor of it.
Can I just clarify on what I was pushing for was really just the Kubernetes interface, implementing as a bag of strings in the CSI layer seems to make a lot of sense because it's most flexible. I guess for me, the class, if we went the class approach, which the opaque strings, I'd suggest not naming it performance class, because it's not going to be just performance class. It's going to be whatever the vendor wants it to be. And secondly, those are, they're obviously class-based. So I'd like to see.
So you're talking about the CSI field names?
No, more the Kubernetes.
Okay, I made the same comment at the CSI layer. If it's literally just modify volume and here's a string map, then yeah, I said we should not call this performance class because it is too generic. It will be used more generically. But at the Kubernetes layer, I actually think there's more value in picking something that suggests how it should be used, and because that doesn't prevent us from in the future making more things that combine with performance classes in terms of how they get reconciled and how they get pushed down to the CSI layer. You could imagine volume performance classes for one purpose, and then encryption classes, who the hell knows, for something else that has maybe a more crisp definition, and then they could, the reconciler would have to take the combination of those and push them down through the CSI driver using the modify volume interface, potentially.
Yeah, the problem is that that's going to take a while to add that field, and in the meantime, vendors have added, whatever they like in there, so it's no longer performance class.
I think that's a good point. I do agree that if if we find that it's getting used for other things outside of QoS, the name performance class is going to be confusing to a lot of people, and people will wonder why it was picked. So I'm okay. I like the idea of calling it something a little more generic.
Yeah. So the other thing I'd like to bring up is, the classes are, they definitely have a purpose, and we would use them, but it doesn't solve the per volume config problem. We want users to be able to set IOPS on an individual volume. So, if we don't go for the first class field, Bram, and I do appreciate that there's challenges with that, then we would like to put forward using annotations for that on a per volume basis. And, we would prefix them and whatever. But to me, they're no less portable than the classes are. But at the moment, that would be discouraged, I believe.
I guess I would disagree that they're no less portable, because I think I'm coming from sort of the perspective of like someone writing a database operator, for example, right? So they could, today, a lot of these database operators, they do provide they do accept, say, like storage class as an input, right? And it's basically up, like I said, to like a platform team to kind of define the portability semantics of it. But, I think from that regard, like a database operator could just have support for the class, and then you can basically run that operator across any platform. Versus with something like annotations, like this operator would now have to encode every platform specific annotation into their logic.
Yeah, I agree with that, but the earlier comment about if you just have one weird volume that you want to tweak, there should be a way to do that. And if we can get the RBAC and quota aspects of that nailed down, I would like to have an answer there. I mean, maybe the answer is you should be the Kubernetes administrator on that cluster and just make your own class and then use it, and you'll get what you want. But like in a shared cluster, the possibility of someone saying, you know what, I'd really like 10 million IOPS today, and just modifying their PVC to get 10 million IOPS feels like not something that there's implications there, right? That you would want to have some amount of control.
Have we considered making this volume performance class namespace scoped?
I think the specific proposal was to do what we do for storage classes, which is make them non-namespaced, but then have the ability to quota them per namespace. So you could say, look, you can use the gold class, but you can only use so many gigabytes of gold in your namespace, right? And the quota would ensure that.
I think if you just go with namespace scope, then you can eliminate certain types of problems, because you can have a namespace for like prod and dev and staging or whatever, and you can specify like the same name for the performance class, and you can be sure that the pod running in the dev namespace is never gonna use the performance that is for the prod namespace.
My intuition there is it's better to have just separate performance classes and then have an admission controller that makes sure PVCs get the right performance class depending on what namespace they're in. Like that seems like a solvable problem without doing per namespace classes.
Yeah, it seems that this sort of duck typing leads to problems longer term. And I just going back a sec, like a big advantage of using classes is we have an existing quota mechanism. If you use annotations, then it does make the adjusting a single volume a lot easier to do. But each cloud provider is going to have to do whatever custom quota management to prevent that from being abused, which you know, is sort of a burden.
Yeah, correct. I think we're just worried that there's so many combinations of IOPS and throughput that,
Yeah.
we sprawl. And how do you describe those to users so that they know which one to use?
Yeah, and I think just going back to your comment about annotations, I think something important to point out here is that AWS already has annotations, if I understand correctly. We're actually planning on doing that here at Google as well, because we have stuff that we would like to launch before the SCEP is going to get out. And it sounds like you're also sort of moving in that direction. So like, even if we arrive here at an upstream solution that does not use annotations, I think the reality is that we are going to have existing implementations that are using annotations. And so coming up with a nice way to either migrate or just have something that like works together with this reality that there are IOP annotations is probably something we're going to want to do. Does that make sense? I mean, like I'm basically saying that I kind of think the cat's out of the bag with respect to using annotations. I think that's something that's going to happen regardless of what we decide to do here.
I think from just like the Kubernetes perspective, I don't think the Kubernetes project should be responsible for trying to solve like custom workarounds and solutions that people have put in place. I think we should concentrate on sort of what is the ideal experience we want to support for our end users.
Mm-hmm. I guess that certainly does restrict the options and make the design problem a bit more tractable. That's fair.
Yeah, and I would agree that from like custom annotations. So just to give you an example, when we talked to one of our customers about the fact that we were thinking of building a custom annotations approach, they were like, "Oh, cool! It's great that you're doing it because we already have something in place that we are using for that." So it's at a point now where that's already something that customers have built some instrumentation around in order to address the lack of a standard solution in this space. And so my take is that they are here to stay. We will probably be supporting them for the foreseeable future, given that we just came out with a solution that provides custom annotations based approach. And I still want to see a standardized solution eventually be in place, and hopefully at some point in the future we can deprecate the custom annotations based approach and just use the standardized solution. But I do want that solution to be broader in scope than just the QoS related parameters.
So I'm trying to figure out if we're coalescing around one idea. Is it that we're generally okay with the opaque params and we just want to change the name from performance class to something even more vague? And that would make everyone happy, or does anyone still think that we have to not do that and find some way of expressing this as first class parameters where everyone just agrees on what they mean?
I'd love to be able to get agreement on this. I just think that there's going to be a much better community user experience if we could. It doesn't sound like we can. If that's achievable. Personally, I think that users will tolerate a little difference between platforms. They do already for CPU request. I think if we label the fields accordingly, then we could reach compromise. I'm not convinced that the classes as they are now is something that kind of fits the way that we want to have users provision IOPS in Azure. But I can definitely see having a generic mutable map would be beneficial for other features. And we could end up using that for performance as well.
So a question I have is in your annotation-based approach, how are you thinking of dealing with quotas, how to deal with if users request more than they actually have quota for in the back end? Like, is there going to be any K8s interface to that, or is it just like they'll have to go to the back end dashboard to see what the state is of their request?
The back end would have to handle quotas, and
yeah.
And we would have to try and report that status back if we had to fail the request.
So if that's the case, then that solution is not really portable across different platforms, right?
Oh no, anything related to annotations is not portable. That's the price you pay when you do the hacky annotation thing. You lose portability.
Right.
In this case, like if a PVC has like an user associates PVC with a non-existent, like there's a default storage class idea, so that makes the PVCs portable. But you have a PVC that has this opaque thing, and you try to use it on a different platform. What will happen?
Those annotations would just get ignored.
Not annotations. I'm talking about this new QS or whatever we end up calling this.
Performance class. I imagine we would need a default for backwards compatibility because lots of apps won't specify anything.
Yeah.
So you'll need to have a default, but I think it's also perfectly valid to have no default because that's what we have today, right? That has to continue to work, in which case you'll get some implicit default that Kubernetes doesn't even know about.
So if I install a Helm chart that specifies this QoS class called foobar, I downloaded it from somewhere. I'm trying to install it. I don't have that foobar performance class. What happens then?
The same thing that would happen if you use the foobar storage class, that didn't exist. You would get
no provisioning.
Yeah, the create volume call would fail, and you would just have an unbound PVC sitting there with the event saying, I don't know what this performance class is.
Yeah, and so I think that's why most Helm charts and operators that I've seen, they have storage class as a configurable parameter. So you can either use it with the default or you can configure one to use.
So yeah, similarly, there will be like, say if we make this a opaque parameter, mutable opaque parameter, actually.
Well, the parameter is not opaque, right? It's the name of a Kubernetes object.
Yeah.
The Kubernetes object contains a bunch of opaque key value pairs.
Yeah. Which are mutable.
No, I don't think so, right?
Well, so the proposal was you could mutate them, but like existing volumes that pointed to it would not get the new values. Like we only would reconcile an individual volume when the name of the class that it had changed. So if it was silver at the creation time and then you go change what silver means, you have to update the volume too to get it to reconcile. So we would say don't change silver, go create a silver 2.0 and change your PVC to point to silver 2.0 if you want to get different behavior, right? Because it's not scalable to make one change to one performance class and have all of your volumes suddenly get updated.
So
there's no way to write a reconciler that does that.
So if you make this performance class a generic thing, and the fields become like a parameters of key value pairs, like let's say they're like mutable but not retroactively applied, then the problem becomes like if that operator author wrote the operator with a certain like certain characteristics of the volume in mind, that would make, and basically because those parameters are vendor specific, they are basically not portable.
Sorry, which parameters are you talking about?
I'm talking about like this. Right now, we are calling volume performance class. No, and we are thinking of making the IOPS and throughput explicit. But if instead we have this parameters that are like it's a hash, it's a map of string or string, and I tested my operator with something and using a certain QoS class, and that storage vendor provided features, I don't know what, because it's a vendor specific features, and then we try to use, somebody tries to use the same PVC, even though there is a QoS
but you have
class.
all of these problems with storage class, right?
So,
The only thing that we're changing is now some of the values become mutable after the volume is created. So like you already have this issue where like, yeah, you could test on a weird system that had a storage class that caused some very special behavior that doesn't exist anywhere else. And if you didn't know that, you're in trouble. So this is not a new problem. It's just now after the volume is created, if you want to go tweak something, you have a lever to do that.
yeah, no,
I would imagine, if say I'm writing a database operator, like I would probably say something like, I would have, like minimum config and recommended config, right? And then so whoever is sort of deploying that operator on a certain platform, they have to make sure they, pass in certain storage classes or performance classes that meet the recommended configs.
It's easy to say that when the parameters are not map of string. When they are explicit IOPS and throughput, we can say that, okay, this is the recommended and this is the minimum we mean. But if they are parameters of map of string, then we cannot say that, because
I think
Yeah, like it would be up to the platform team to like have to map those requirements.
yeah,
And it's always going to be hand wavy with performance, right? Because it's very hard to characterize, this is the performance I need, and it's going to be the same everywhere. Because
like I think there's going to be things where 1,000 IOPS on Google is like has some slightly different performance edge cases than on AWS, so there's going to have to be tweaks no matter what you do.
Yeah, sorry, and then one more question. If you don't want to call it volume performance class, what is a proper naming?
Oh no, the hard question.
I work for volume attribute class.
Oh, okay.
Volume attribute class.
Yeah, that sounds
pretty cool.
reasonable.
Okay. Cool.
I'm worried though, because that basically opens us up to specifying features that are the flags which require broader support from Kubernetes, like somebody like Rishabh said, multi-attach or something else. People put
I don't think it does. I mean, I think it has the same implications as storage class. And we can specifically say, like, look, if you do anything with your opaque parameters that like break CSI, like that's your fault, right? There's no guarantees that the stuff is gonna, because we own the community, we own all the sidecars, and they're not going to change as a result of anything other than the simple reconciler that says, look, if the name of the volume attributes class changed, we're going to call modify volume until it returns success, and then we're done. And that's literally all the reconciler has to do, is it has to watch the name of the volume attributes class on each PVC and have a spec class and a state class, and when they're not the same, it has to reconcile them. And everything else is just exactly the way it is. And yeah, like I don't understand what multi-attach means, because Kubernetes specifically handles multi-attach with its access modes and the attach detach, or sorry, publish unpublish workflows. But I think that there's plenty of subtle behaviors that are currently being smuggled in through storage classes where there's just no way to change them after you create the volume, and this gives you the way to change them, and it's not that dangerous.
Yeah, I would agree with that. Rishabh, did you say volume attributes class or volume attribute class? The plural or the singular for the volume attribute?
Either.
Okay,
Volume attributes class, because there's more than one.
that's what I would imagine, but
Okay.
It wouldn't make sense to apply quota on volume attribute classes though, generally.
Well,
I mean, we could, but
I mean, quotas are not required, right? By default, there are no quotas. So like, I think we would have to just, in the documentation for this feature, say, you know, specifically suggest that this feature is used for stuff like performance, and you might want to quota that. But yeah, out of the box, I think your quotas are infinite, so there's not an issue.
no, but are we going to put something in resource quota where this proposal as is volume performance class name dot count? Like how many
Yeah,
like
like
PVC
if you have like your red, green, blue attribute classes, and you can have a quota that says you can have 5,000 gigs of red and 2,000 gigs of blue and whatever. I mean, that can make sense if you know what you're doing.
500 gigs of red.
I mean,
That's
that's how storage class quotas work now, right? You can name your storage classes whatever you want, and you can quota them however you want, and whether they make sense depends on how you did it.
yeah. Like the counting is easy, size is hard. So I mean, so if you're gonna
For this feature, we are just thinking about like you can restrict how many PVCs for volume attributes class.
yeah, I mean,
All right, I have a hard stop in like 2 minutes.
yeah, same here.
Do we need a follow-up meeting? I guess that's the important question. Or do people feel comfortable enough with this path forward that we can update the spec, get everyone to read it and review it and approve it and move on?
So can I just confirm that neither Google, Amazon, or any other vendors in the room think that we can reach an agreement on first class parameters? Because if I'm the only one, there's no hope, right?
Yeah, I mean, I think we are at Google supportive of this. All that said, like, you know, as I mentioned, and I think we are going to have annotations as well, you know, just because that's a pragmatic shorter term.
And also a little bit background. Actually, the first class IOPS throughput works very well with our PD product, but it's because we see some other storage vendors use case and think like this mutable parameter solution, it's like just fits into my boxes.
Yeah, we at AWS is also supportive of this approach.
I will say I think we could come to an agreement on our first class parameters, but I think the end result would be way fewer vendors would implement it in the long run, and we would end up changing it inevitably at some point. I think that's what would happen if we went down that path. We would realize that we weren't happy.
Yeah, I just want to say like going with this path, I feel like we're not walking through any one-way doors in the future. Like going with just IOPS and throughput, I think we might be walking into one-way doors that's going to hard to revert in the future.
Yeah.
I was hoping we could get a combination of the two, where we've got the first class for IOPS and throughput, and then we have the mutable bucket for vendors who either can't support it directly or for other options.
I would personally would have preferred to have first class fields in the listing rather than having a bucket, because I can see how it could be misused and like not misused, but like I don't know, can cause problems. I think misuse is too strong a word. I would also like to know how it would work retroactively, like user mutates the parameters and then like Ben said, okay, it won't apply to existing
Yeah,
volumes.
I mean, I think the proposal we're saying it's not mutable. I think originally we thought it would be mutable, but we got rid of that, and now we're saying it's going to be immutable.
But then so if somebody wants to change their storage, this volume attribute class, then they basically have to create a new volume attribute class and associate that PVC with that one.
That's right.
But that's good for other reasons, right? Because then all your other ones that you don't change still point to something that's accurate and not inaccurate. So if you have silver and you make silver v2, then all your other silver volumes still point to silver, and your new one points to silver v2, and it makes sense until you change them all.
Yeah, but that's assuming that you want to use classes and not per volume config at all.
Right. All right. We may need another follow-up meeting if people are still on the fence and not thrilled. But I have to drop. I'm sorry.
Yeah.
Okay.
Yeah, same here.
Well, thank you everyone for your time and for listening to me.
Yeah, no, this is good. I think this is all exactly the right discussion to have. So it's a hard question.
Thank you.
Yeah, agreed. Thank you.
Thanks all.
Bye.